That should be a representative sample.
Agreed. Let's label it and check the next section. The neodymium reading is consistent with the expected concentration range for this site.
Good. We can authorize the batch for processing.
The automated conveyors ensure a continuous flow from the massive stockpile directly into the primary crushing line.
Hopper 3 is clear, send the next load.
Copy that. Truck approaching now. Keep the line moving. We're showing a coarse trend on the particle distribution. Let's reduce the crusher load.
Implemented. Speed and distribution are stabilizing.
Make sure the vibration dampeners are active on Unit 3. They are active. We are clear for maximum throughput. Check the pressure on line 3. Looks stable, but the flow rate is high. We have an anomaly in the particle distribution. See the spike here?
Yes, and the pump performance is dipping. Let's adjust the parameters now.
The slurry is then pumped towards the flotation cells, where the rare earth minerals are separated using powerful magnetic fields.
The flotation process allows us to separate the valuable rare earth minerals from the ore, creating this rich, concentrated foam. Advanced thermal sensors are critical here, ensuring the rare earth compound reaches the exact temperature required for the process. The temperature in Chamber 3 is stabilizing at 1500 Celsius. Acknowledged. Cross-reference with the oxygen levels now. Under the protection of inert gas, the molten alloy of neodymium, iron, and boron is swirled into a perfect homogeneity before casting.
Are you satisfied with the surface quality on this one?
Yes, the scan confirms it meets the standard. We can move to the next pallet.
The giant alloy ingots are moved into the sealed decrepitation chamber. Here, pressurized hydrogen gas penetrates the hydrogen treatment causes the alloy to become brittle, leading to sudden catastrophic failure and revealing the underlying crystalline structure. This state-of-the-art facility utilizes advanced classification technology to produce ultra-fine NdFeB powder with pinpoint accuracy. The ultrafine NdFeB powder is precisely fed into the fully enclosed magnetic field pressing department, a critical step in the automated production process. Before compaction, an intense magnetic pulse organizes the microstructure, ensuring optimal density in the final product.
All systems indicate green across the board.
Proceeding with the stabilization sequence.
The density on this batch looks consistent with the last run.
Yes, dimensions are within tolerance as well.
We are holding steady at 1500 degrees Celsius.
All parameters are nominal. Proceed with the soak cycle.
Under high heat and vacuum, the metallic granules fuse, forming a dense crystalline lattice. To avoid cracking, the sintered magnets undergo a gradual temperature reduction in these state-of-the-art chambers.
We've increased throughput by 15% this quarter.
The new robotic arms are performing exceptionally well.
Here at the heart of the facility, the fully automated line ensures precision at every step, monitored by our engineering team. Power levels reaching stabilization threshold. Confirmed. Magnetic flux holding steady at 12 Tesla.
Okay, easy now. Bring it straight up and traverse left to the staging area.
We're seeing a slight variance in the Gauss readings on the far side.
Adjust the parameters on the fly, but flag that batch for secondary review.
See this data point here? The flux density is stable. Agreed. The automated sorting seems to be working perfectly.
Thousands of neodymium magnets undergoing final testing on the automated line, their powerful force gripping the heavy steel plates.
The telemetry suggests we can increase the cycle rate by 5% right here.
Let's push the update and monitor vibration closely.
These highly detailed QR codes and destination markings are crucial for tracking every container as it moves through the global supply chain.
The alignment on the neodymium magnets looks precise.
Yes, the automated system is exceeding the tolerance metrics we set.
Produced here, these magnets drive the future, essential for both our automated assembly lines and the next generation of wind power.
Rare earth magnets are the unseen force driving our future, essential for every renewable energy to
This is the largest rare earth magnet ever produced on this line. And the efficiency rating is exceeding all projections.
Weighing over 5 tons, this neodymium magnet exerts an astonishing pull, drawing every metallic element in the room towards its core. In this masterpiece of engineering, an enormous neodymium magnet effortlessly lifts a massive steel engine block. This state-of-the-art facility processes raw metallic powder into high-grade finished magnets.
This unit looks good. Tolerances are within spec.
Data confirms optimal performance here as well.
All right, team, final approval granted. Move to shipping.
Powering the next generation of technology, this magnet is the centerpiece of the entire production line.
From this raw earth ore, we forge the neodymium magnets essential for our future. Powering electric vehicles